Good morning, students. Uh, Course is Analog and Digital Communication. The topic is Introduction of Digital Communication. This is from the third unit of our ADC. And next, in this topic, at the end of the session, you will be able to know the introduction of digital communication, know the advantages of digital communication. Next, coming to digital communication. Digital communication. What is digital communication? Digital communication is the process of device communicating information digitally helps the reader to get a good idea on how the signals are digitalized and why digitalization is needed. By the completion of this tutorial, the reader will be able to understand the conceptual detail involved in the digital communication. The communication that occurs in our daily life in the form of signals. These signals, such as sound signals, generally are analog in nature. When the communication needs to be established over a distance, then the analog signals are sent through wires using different techniques of effective transmission. The necessity of digitalization, why we are using the what is the necessity? These are the analog signals and these are the digital signal representation. Then now we are going to know what is the necessity of digitalization. The conventional methods of communication used analog signals for long distance communication, which suffers from many losses such as distortions, interference, and other losses, including security breach. In order to overcome these problems, the signals are digitalized using different techniques. The digitalization signals allows the communication to be more clear and accurate without any losses. The following figure indicates the difference between analog signal and digital signals. The digital signal consists of zeros and ones. This is a pulse train which is consists zeros and ones, which indicates high and low values respectively. Next, coming to advantages of digital communication. As the signals are digitalized, there are many advantages of digital communication over analog communication, such as the effect of distortion, noise, and interference in much less in digital signals as they are less affected. Digital circuits are more reliable, and digital circuits are easy to design and cheaper than analog circuits, because in digital circuits we have to transform the data throughout air, but coming to analog we are transforming data through wires like coaxial and optical fibers. We have to use the rate of these wires and optical fibers are more when compared to digital circuits. The hardware implementation in digital circuits is more flexible than analog. The occurrence of crosstalks is very rare in digital communication. The signal is unaltered as the pulse needed a high disturbance to alter its property, which is difficult. And the probability of error occurrence is also reduced by employing error detections and all. Spread spectrum technique is used to avoid signal jumping from one signal to another. Combining signal using time division multiplexingers are used easier than combining analog signals using frequency division multiplexing. Next, coming to the capacity. The capacity of the channel is effectively utilized in digital signals. Many of the digital circuits have almost common encoding techniques and hence similar devices can be used for the number of purposes. And these are the elements of digital communication. Here we can send a source as to the input transducer like in already we have discussed it earlier in analog communication. Same as for digital communications also we have to use analog to digital converter like transducers to source encoder. Here we can use source encoder to encode the input signal, and channel encoders also use it and given to digital modulation and D2A converters through channel. Then here we are using some A to D converters. Source to channel also we have to use A to D encoders. Again digital. Here we are also using D to A converter because the data is in digital form, we have to convert into analog form because the channel can sends only analog information. So we are converting D to A converters to convert the signal into digital to analog. Again, the digital demodulation and D to A converter, the data which is coming from the channel is also again converted into digital. Then we are using channel decoders here to get the demodulated information and source decoder. Last, we have to use again output transducer and D2A converter. These are the explanation for the elements of digital communication for every block. Why we are using transducers, what is the uses of source encoder, what is channel encoder and digital modulator and digital demodulator, channel decoder, source decoder, output. So we have to see the sections of digital sound. The source. The source can be analog signal. Example, a sound signal. Input transducer. This is a transducer takes a physical input and converts into a electrical signal. Example, microphones. This block also consists of an analog to digital converter where a digital signal is needed for the further purpose. A digital signal is generally represented by the binary sequence. Then source encoder. What is the purpose of source encoder? The data into minimum number of bits. The process helps to utilization of the bandwidth. It removes the redundant bits, unwanted bits. Then it gives the output as zeros. Then coming to channel encoder, the channel encoder does the coding for error correction during the transmission of the signal. Due to the noise in the channel, the signal may be altered, and hence to avoid this, the channel encoder adds some redundant bits to transmit data. These are the error correcting bits. Next, digital demodulator. The signal to be transmitted in digital demodulator by a carrier. The signal is also converted to a analog from the digital sequence in order to make it travel through a channel or medium. Again, channel. What is the purpose of channel? We have to write and channel decoder, source decoder, output. Next, coming to comparison of the analog and digital communication. Analog and communication uses a analog signals for transmission of information. Slightly, digital communication uses digital signals for the transmission of information. Analog communication uses signals that can be represented by sine waves. Digital communications uses signals that can be represented by a square waves. Next, these are the comparison, analog communication and digital communication. In analog communication, we have analog in nature. The signal is analog in nature. Here, the train of digital pulse we have to use. Then amplitude, frequency or phase variation in the transmitted signal represents the information or message. Next, coming to digital, amplitude, width or position of the transmitted pulses is constant. The message is transmitted in the form of code words. Next, similarly, the noise immunity is poor in for AM but improved for FM and PM. Noise immunity is excellent. There is no noise in digital communication. Coding is not possible. Coding techniques can be used to detect and correct the errors. Bandwidth required is lower than that for the digital modulation method. Due to high bit rate, higher channel bandwidth is required here. Then here we are using FDM. Frequency division multiplication is used for multiplexing. Time division multiplexing is used for time multiplexing. Used for multiplexing. Not suitable for transmission of secret information. In analog signals, we cannot transmit secret information. So we are not using this in military applications. Due to encoding technique, it is suitable for military applications. Analog modulation systems are AM, FM, PM, PAM, P. So this is PWM, pulse width modulation. Next, digital modulation system are PCM, DM, pulse code modulation, delta modulation, adaptive delta modulation, differential pulse code modulation, etc. are the examples for the digital communication. Next, modulation. Modulation. All we are discussing about only modulation. Our topic is also based on the modulation only. So, what is the modulation? Modulation is the process of varying one or more parameters of the carrier signal in accordance with the instantaneous values of the message signal. The message signal is the signal which is being transmitted from long distance transmission. There are many modulation techniques. We are classified according to the type of modulation. Of them, all the distal modulation techniques used in pulse code modulation, PCM, pulse code modulation. A signal is pulse code modulation to convert into analog information into a binary sequence that is ones and zeros. The output of pulse code modulation will resemble a binary sequence. The following figure shows an example of PCM. Output with the respect of instantaneous values of given sine wave. This is the sine wave input and we are giving PCM output like this. Next, instead of pulse train, PCM produces a series of number of digits and hence this process is called a digital. Each one of these digits through in binary code represents the approximate amplitude of the signal sample at the instant. In pulse code modulation, the message signal is represented by a sequence of coding pulses. This message signal is achieved by representing the signal in discrete from in both time and amplitude. The next topic is pulse code modulation. Okay, these are the sample short question answers which are given from the above discussed topic. And next, we will discuss. Thank you.